Labguy here. I've been working on the Tiny Ike Iconoscope television camera project now for 4 years, and I've finally reached a point where I am making an image. I have no sensitivity in this camera yet, not that it's ever going to have a lot, but it can now see a flashlight. What impresses me is that this is a round flashlight. Look at the linearity. The scan geometry is really good. So there you go. A high intensity flashlight shown directly into the camera, and it can see that. Here's an overview of the Tiny Ike camera project. It has the AC entry and power transformers, DC power supplies providing high voltage for the tube, medium voltage for deflection and blanking, and 4 low voltages for my op amps and sync generator. The tube lives inside a shielded box, and the box contains a buffer board with some bypass filters for the electron gun. I have very clean DC voltages going to this tube. Over here I have the video preamplifiers, a 4 transistor stage with an FET front end, which comes over and feeds the video chain, which is these 3 red boards, which consists of 12 video op amps. Here's the sync generator section, blanking section, horizontal deflection, and vertical deflection, all on this little tiny board. Deflection is electrostatic, and so I use high voltage differential amplifiers to create the differential drive at high voltage for the tube. The blanking is about a 30 to 60 volt pulse applied to the grid to cut the beam off during retrace, and a voltage divider, which I thought I needed for bias on the Mosaic, but it turns out the Mosaic load resistor simply goes to ground. So there it is, the Tiny Ike Iconoscope television camera project, working for the first time. What the heck is that? Well, it appears to be a 5527 monoscope viewed from the inside by some severe overscan. It's kind of behaving like a monoscope tube, and we're seeing some of the structure in the end of the tube. I have to adjust the size and centering to put our scan area inside this inner circle.